Hello everyone, let's try to be a cheat code ninja today. In this problem, we are given a positive integer n representing n cities from 1 to n. We are also given a 2D array representing the roads between two cities and their distance. Each road is bidirectional, hence we can go to and fro on the same road. It is also given that the graph may not be connected. What it means is that there can be unconnected components and there is no road connecting them. The score of a path between two cities is the minimum distance of any road in the path. And we have to return the minimum score for the path between cities 1 and n. It is also given that we can travel on the same road multiple times in a path and we can visit any city multiple times. It is also mentioned that the cities 1 and n can be reached by a path. Hence it means that they are part of the same connected component. In the given example, n is equal to 4 and we have to find the minimum score for the path from 1 to 4. What it means is that we have to find the minimum road on which we have to travel from 1 to reach 4. Hence we'll travel the cities 1, 2 and 4. The minimum road in this case will be 5. Hence that is the answer. Let's try to come up with an intuitive solution for this. Let's modify our original example so that the minimum distance of any road in our component will be this. We still have to travel from 1 to 4. But since we are trying to travel on a road which is of the minimum distance, we won't be taking the shortest path. Instead, we'll be traveling city 1 to city 2 and then city 3 and then back to city 2 and then city 4. As we are allowed to travel to a particular city as many times, we are visiting city 2 twice. We are also traveling on the road city 2 to city 3 twice. And because we can visit any road or a city multiple times, we can go through all the roads in our component and try to travel on it once. This would minimize the score for traveling from city 1 to city n. So this problem can be redefined as finding a road with the minimum distance in our component. And since our answer will be a road from this component, the other unconnected components are of no use to us. And we are also given in the question that the city 1 and n will be in the same component. So we can start at city 1 or city n or in fact any other city in that component and we have to go through all the roads and find the minimum. This can be done using a DFS or even a BFS traversal. But we have to be careful of certain things that will be evident in the next example. This is our connected component and n is equal to 3. In this case, the answer should be 2 because it is the minimum distance of any road. But if we do a DFS from 1 to node 2 and then node 3, we haven't yet covered the road 1, 3. And when we reach node 3 and see that node 1 is already visited, we generally skip it in our DFS logic. But this will lead to a wrong answer because the road connecting them is the shortest. Hence we should consider all the roads as our answer even though it connects to a visited city. Even though we won't be doing DFS again on city 1, but we'll still be considering the road from city 3 to city 1. The time complexity of this would be, we have to go through all the cities and all the roads, hence it would be O of n plus e, where n is the number of cities and e is the number of roads. And the space complexity would be, we have to keep a visited set to store all the cities we have visited. This would take O of n heap memory. We'll also take O of n stack memory because of a recursive call stack. Let's implement our solution. Let's define a hash map to create our graph. Now we'll go through all the roads. And since our roads are bidirectional, we'll be storing 2 entries in our hash map for both the cities. We'll also be storing the distance of the road in each entry. Let's initialize our result to be infinity. We are storing this in a list so that it will be available in our DFS function. We'll keep a visited hash set to store the cities we have visited. Now we'll define our DFS function where the input would be a node. The first thing that we'll do is add it to a visited hash set. We'll be going through all the roads for that node and retrieve the city ID and the cost of going there. As we have to consider all the roads, even though it leads to a visited city, we'll check if it is the minimum road we have seen so far and update our answer. To avoid going through the same cities in a cycle, we'll check if that city is already visited, we'll continue in our loop. And if that city is unvisited, we'll call DFS on that city. We are done with our DFS function. We can now call DFS on any city in our connected component. We know for sure that city 1 is a part of that component, we'll call DFS on it. And finally, we can return our answer. Let's submit our solution. As you can see, our solution is accepted. If you have any doubts or concerns regarding this solution, please mention in the comments. If this video was helpful, please support this channel by liking this video and subscribing to the channel. Thanks for watching.